All right, there we go. And so, welcome. We have a really great presentation today from Eileen Campbell, and Eileen is the supervisor for the long-term surface water data unit here at the Minnesota Pollution Control Agency, the MPCA. And so her journey began at the MPCA in 2004 when she joined as a student worker. And so over the years, Eileen has held various positions, specializing in stream monitoring, data analysis, and data management. And so thank you so much, Eileen, for being here today, giving us this awesome presentation. I know a lot of you volunteers dealt with some rain, a lot of rain earlier this year, and so we'll be learning a little bit about some of those events. And yeah, take it away, Eileen.
Thanks, Waverly. I'm happy to be here and chatting with everybody. A little bit about kind of the Watershed Pollutant Load Monitoring Network, and then I'm going to share some pictures and video and some data of what we found in the Blue Earth River after that Rapidan Dam partial failure. So I supervise the long-term surface water data unit at the MPCA, and there's three parts to this unit. So volunteer water monitoring program, so that's you all. So you know a lot about that, a lot more than I do, probably. And then we have a continuous nitrate sensor network that's brand new, out of money from the legislature this past session that we will be developing, and maybe in a couple of years we can come back with some results and some data on what we're seeing with that nitrate sensor network. But today we're going to be focusing on the Watershed Pollutant Load Monitoring Network, which we also call WPLMN or WPLMN. WPLMN has a few different program purposes. We utilize it for a statewide comparison of water quality, looking at where things are higher, where things are lower, where we would expect them to be higher or lower, and how they relate to sort of normal conditions. The data that we collect can help us determine, for instance, if the sediment is coming from sort of higher up in the watershed toward the headwaters, or if we're seeing more of it downstream with bluff erosion, for example. It helps us track trends over time to see how we're doing with a few of our water quality parameters. And then our data is foundational. It goes into a lot of chemistry reports to help us understand basically what's the problem, where's the problem, how do we address it? So it goes into all of these other reports that kind of cascade through the agency and then into other plans such as the One Watershed, One Plan that all of your local water planning organizations do to help put BMPs on the ground, those best management practices to find ways to improve water quality in Minnesota. WPLMN is a network of almost 200 sites across the state of Minnesota. We have 3 different levels of sites. We have basin sites, so that's those green squares on this map on the right. These are sites that are on main stems of some of the major rivers. So the Red River, the Minnesota River, the Mississippi River, the Rainy River, and the St. Croix River. These sort of give us, well, and I guess the Cedar River and the Des Moines River. These give us sort of our backbone, and then we sort of go smaller and smaller into the watersheds after that. So the major watersheds are the blue circles that we see on the map. Examples of those would be the Blue Earth River or the Lac Parle River, Zumbro River, Wild Rice River, Baptism. So these are stations that are at the outlet or near the outlet of some major pour points around the state. Both the basin and major watershed stations are monitored year-round, so we have an understanding of pollutant loads throughout the entire year. At a smaller scale, we have our subwatershed sites. These are the red triangles on the map on the right. And these are kind of further up in the watershed. So it might be something toward the headwaters of the Big Fork River, or down by me in Mankato, the Maple River, or the Cannon River, or the Straight River that goes into the Cannon River. So these are sort of smaller scale watersheds, but not the smallest scale. They're still relatively big. This network started in 2007 with the major basin sites, and then we added the subwatershed sites around 2013. So we're really starting to gather a good amount of data to understand these conditions and trends across the state of Minnesota. We did have a network prior to this called the MPCA Milestone Sampling Network that, if you've been in water quality at all, you might have heard of. So this essentially replaced that. This is event-based load sampling. So we are going out after rain events to try to capture the rising limb, the peak, and the falling limb on these streams. And we have staff within our agency that do this sampling. But then we have a lot of really awesome local partners that help out that we give money to do this sampling as well. So soil and water conservation districts, Metropolitan Council, Natural Resources Research Institute at the University of Minnesota Duluth are just kind of some examples of scales of partners that are with us in how we do this data and collect these samples and analyze these data. The flow data we use comes from the Minnesota Department of Natural Resources, USGS, and then we have one Water Survey Canada site up at the top of the northwest corner of Minnesota, right before the Red River goes, or right after the Red River goes into Canada. If you want, there's a QR code on the screen, but I can share some links for some of these websites as well if you want to look at the data. We do put all of our data online. It's public data. It's there for people to look at, to kind of dig into and understand what's going on with your water around the state in terms of concentration and load. We do have a limited number of pollutants that we are monitoring with this watershed pollutant load monitoring network. We're looking at total suspended solids. So this can be either sediment or algae that make the water cloudy or look like chocolate milk, or you can't see through it well. So that causes issues for good aquatic plants that we want living in our streams. They don't have the light to photosynthesize. When some of that material settles out on top of things on the bottom, you might have impacted habitat. You might have macrovertebrates, the bugs that live in the rivers, kind of get covered up, or maybe smothered fish eggs. And it, for recreation, it's not something that we always, when I talk to kids, I'm like, hey, if you saw a stream that looked like this, would you tell your parents, hey, why don't you pull over and we can go for a dip? It just doesn't look that great most of the time. And it's important to note that, we're not expecting drinking water clear streams. Like, that is not our goal in Minnesota. They're kind of cloudy in southern Minnesota, especially. There might be drinking water clear in the north, but there's also always going to be a little bit of color to the water. Phosphorus is where we start to get algae growth. So in freshwater systems, phosphorus is a limiting nutrient. There is enough phosphorus, or there's everything that algae needs to grow, except for they don't have enough phosphorus. So when they get that, it's sort of like a buffet for them, and they go crazy and they grow. Once those algae start to really grow and become an algae bloom, that starts to die. You have bacteria coming in, eating all the algae. Those bacteria use the oxygen in the water. And so that's where we start to see low oxygen levels and possibly fish kills. The other thing that we monitor is nitrogen. There's a few different types of nitrogen. We look at nitrate nitrogen, so the inorganic, and then we do look at an organic nitrogen as well, which I'll talk about a little bit later. Nitrogen can cause like blue baby syndrome. There's increasing information, I think, about on the Department of Health's website about possible other health links for adults. It's toxic or can be negatively impacting fish and macroinvertebrates that live in the streams. And we're all connected. We're a headwater state in Minnesota, and it's going to go downstream and contribute to that dead zone in the Gulf of Mexico. So that's where we have low oxygen there from nitrogen growing algae, and contributing to fish kills and shellfish kills down there. We are going out to the streams, much like you do, for those of you that in the volunteer stream monitoring program, or for the lakes, doing a field visit, collecting information. We have a tool that helps us do that. We get water, we put it in sample bottles, and then we send that to labs. On the bottom, sort of left-hand part of the screen, that's a hydrograph, so a graph of the flow on the y-axis, all the little tiny blue dots, and then the red dots are our samples, so all of the times that we sample. So that kind of gives you a sense for how many times we sample. We try to get out to stations 25 to 35 times a year to really help us understand those pollutant dynamics. We sample a few different ways. We have a telescoping rod that we might utilize in some instances. This Van Dorn sampler in the center, that is, it kind of goes into the water horizontally, and these sides come up, and then you send a little messenger down that clicks that bolt on the top and basically snaps the water and captures it in there. And then sometimes we collect samples by hand. We're really trying to collect samples in the center of the stream. We want to make sure that they're just under the surface of the water so that we aren't capturing any of that surface debris into our sample. Once we have those samples, those get sent into the lab. We also collect some field data information when we're out there. So we do collect information just like you do on appearance and recreational suitability. We collect Secchi tube measurements, and we're looking at, what we're seeing around us, what's going on in the stream, what's happened for the weather, all those kinds of things to help us correlate this information later. When we get the data back from the lab, this really should be a times symbol instead of a plus symbol, but we have a concentration from the lab of that pollution. We have the flow from our great partner agencies. And when you multiply those two things together with some conversion factors, you get a load, so a massive sediment that is going down the stream. So you could think of, if you dried all the water off of all of the dirt that went past one of our monitoring stations and weighed it, that's our load, so the mass that we have. We also calculate something called the flow weighted mean concentration. It's sort of an average concentration across the year. That's like if you collected all the water at one of our monitoring stations into a big bathtub or a big swimming pool, stirred it all up, and collected one sample. So that's what we're seeing in some of these maps that I'm going to show you with some data, is that flow weighted mean concentration. This is an average over multiple years. And you can see that there's some different gradients to this. One thing to caution, don't think of this as really bad to good with green to red. It is just sort of a gradient. We don't expect that something on the North Shore is going to have the same water quality as something in South Central Minnesota. But you can see, this gives you a sense of where there is more of a pollutant than there is in other places. So this is total suspended solids, so most of that dirt and a little bit of algae in the river. You can see that it's higher in South Central, Southeastern Minnesota, Southwestern Minnesota, and a little bit up into the Red River Basin. You also might notice that there's a red spot sort of right at the crook just south of Duluth. I think I can probably do a laser pointer now I'm thinking about this. Right here, that's the Nemadji River, and that actually has some kind of really interesting geology that puts it into a slightly different categories than some of the other stuff there. So you can really get a big, like a really big overview of what the state of Minnesota looks like for all these pollutants. This is total phosphorus. And this is the nutrient, like I said, that grows algae. You can see that it has kind of a similar pattern to total suspended solids, where we're seeing the Red River Basin, kind of the Missouri in the Southwest, West Fork, Des Moines, Minnesota River Basin, and Lower Mississippi really have higher levels of phosphorus than a lot of the rest of the state. And you can see that the Maggie River sticks out there a little bit as well. Nitrate is a little bit of a different story when we're looking at how that is distributed across the state. The Red River doesn't have the elevated nitrate levels that we see in southern Minnesota. And you can see that there's sort of hot spots a little bit more than there are with some of these other parameters that we look at. So we're putting all this information. We use a lot of models with our data. We're combining those samples and that flow together, and we get something like this. So this is what our water specialists are kind of looking at over the winter when they're not sampling. They're staring at screens, calculating and helping estimate what this is on a daily basis. So we have annual numbers, and then we also have daily numbers. So this sort of darker green line is the flow. These hollow green triangles are our estimations of concentration, and the yellow dots are our samples. So we use different types of models and relationships to be able to estimate what's going on between our sampling. This is total suspended solids again. This is the concentration, so kind of that milligrams per liter of water or parts per million, and the date. And so then we're able to understand a little bit too about, hey, when flow goes up, TSS usually goes up. And it changes for different parameters. So there's a lot of really interesting things that we get out of that. But just wanted to give you an example of sort of a data product. All of this daily data is available on our data viewer website for you to dig into if you really want to know a little bit more about how concentrations and loads change at streams near you. So that's kind of it for the condition part of the Watershed Pollutant Load Monitoring Network. And so I'm going to talk a little bit about trends. This is another QR code. We can hopefully really send out some links after this so that you guys can have access to all of these things. They're all public dashboards where you can go and dig into what's going on with the trends. Not gonna get too into detail. This could also be an entire talk by our statistician Jimbo Jans. He's our hydrologist stats person, and he definitely spends a lot of time making sure that we are using appropriate statistics to calculate these trends. When you go to the website, there are some different time periods that we use, but we're just going to sort of look at sort of these 10 or year trends or so. These go to 2019, and we're working on hopefully in the next couple months getting these updated all the way through 2022. There's different types of trends. We're going to be looking at, we'll just focus on the flow corrected trends. This gives us sort of an understanding of what's going on in the rivers, whether it's getting better or worse if you don't consider flow. So if you assume that the only change is what happened in the concentration of that pollutant getting onto the landscape. In that instance, you can see that when we're looking at TSS, all these green arrows show that it's getting better. The boxes, the gray boxes, mean that there's no significant trend. We can't tell if it's getting better or worse. We just don't have enough data. And then we do have some increasing trends in TSS as well. When we only have a few years of data, one dry year like 2020 or one really wet year like this year can really impact and skew that. So it's really important to get as many years as possible to be able to understand how this works. When you don't correct for flow, you are basically introducing all that extra water. This helps us understand, because of increased precipitation, and increased flow, what might be happening to the concentrations in our river because of that increased amount of water in the river. You can see that we have a lot more places where we have increasing trends. So the water quality is getting worse. There's more sediment in our streams. And a few places sort of similarly to non-flow corrected where we don't have any trends, or we have improving trends. When we look at total phosphorus, it's a kind of a different picture, especially when we take out the flow impact of it. Total phosphorus is something that we've really been able to target with our regulations of the agency. We are a regulatory agency, so we can work with point sources, so like wastewater treatment plants, industries, to have permit limits that are set for them to say, hey, you guys, the technology is there. We're going to make sure that you have a permit that says you can't put more than this amount into the river. And so the work that our agency has done on that has really shown up in our trends with this network. There's a little bit of a different story when you start to pull in all this extra water that we're getting. So with climate change, Minnesota's getting warmer and wetter, especially warmer in the winter. In general, overall, but we see that with our when we start to take flow into consideration. Nitrate's an even different story. It's basically increasing everywhere across the state, and so that's kind of part of why we're getting that continuous nitrate network. I'm sure you've seen things in the news if you pay attention to water quality and news about nitrate. There's concerns here for drinking water, as well as things that live in the stream. So it's definitely a place where we're hoping to continue to dig more into at the MPCA for monitoring, so that we have that data to pass off to the other people who are kind of down the data path from us, to make some decisions about how we handle that. That's it for trends. I'm jumping around a lot here, but the next thing I'm going to talk about kind of for the, probably next 10 minutes or so, is the Blue Earth River near Rapidan partial dam failure that happened this summer. So I live in Mankato. I'm pretty close to that. We have a monitoring station for the pollutant load monitoring network that actually generally sits basically down here, so not too far downstream from the dam. And we haven't been able to get there since then. Our local partner here is Minnesota State University Mankato Water Resources Center. So between the water monitoring staff there and our staff, we were able to collect a lot of data right after the event, and she actually collected a sample on the day before the event. So you'll see some of that in here. So she collected a sample on June 23rd. The partial failure happened on June 24th. And then we were able to get out there again on June 26th. But we're sampling at a stream, at a bridge further downstream. For those of you that are stream monitors, these should be pretty familiar numbers to you. These are Secchi tube measurements. What was really interesting about this event is that the material behind the dam was very fine, and it basically was nothing, basically zero. When I went out on the 26th to collect the samples, was just barely 1. It stayed that way for a little bit. Was slowly getting up to 2, 3, 4, 5. And this is well a month over after this happened. You can see that generally, we might have a decreased clarity in the stream, but it usually will get back up to 15 in the summer. In the wintertime, we're even approaching, plus 100 Secchi tube measurements. So this stream should be clearing up more than this. So it's definitely abnormal for the stream here at early November to only be 22 centimeters. When we expect, I think last year it was 70 centimeters at this time, which is a little bit more normal for not having a storm event. There's definitely impacts to the stream that are still occurring related to sediment and water clarity in the Blue Earth River right now. And I expect that as we get rain events next year, some of that sediment, which you'll see in some of these other pictures, that's in the stream channel is probably going to move back into the flow and move downstream. And we'll probably see these decrease again and probably take a little while to clean up. And who knows? That's kind of going to be an interesting part of the next few years, is seeing how long these impacts last from this dam failure. A little bit of what this looked like. This is 6/26, so 2 days after, when there was passable roads to get back out. The stream was really just like churning. It was almost looked like mud moving down the river. And I've been sampling streams for 20 years, and grew up by the Le Sueur River, and I haven't ever seen anything that looked quite like this in my life. And this is the sample jar sitting on my desk. And I actually still have that sample, probably keep it for as long as I can, just because of just how strange it is compared to what I've seen. But it was black, so there's some smells sort of to this. It smelled a little sewery when you were out there. So some of these anoxic or low oxygen conditions that existed sort of in this buildup of sediment behind the dam from 100 years was there. It drained the oxygen out of the water. So we did have some fish kills after this event as well. The oxygen rebounded relatively quickly. The fish, however, probably haven't come back. The DNR was out a couple of weeks ago doing fish surveys on this part of the Blue Earth River. So it'll be really interesting when they come out with their results to see what they have found. And then the MPCA, we have fish crews and macrovertebrate crews that will be sampling beginning, I think, in a couple of years here out at the Blue Earth River, as well as part of our cycle of watershed monitoring, more intensive watershed monitoring. So how did this reflect in the actual sample data? We had levels of sediment that we have never measured on the Blue Earth River before. This data, these statistics, so we have the median, so sort of like, it's usually a little bit in our streams here, probably a little bit higher than the mean, but pretty similar. So that middle value of all the values we've ever collected at this site, the 90th percentile, 95th, 99th. So these are, if you put all of our data in a row from smallest concentration to largest concentration, and let's say you had 100 data points, this would be what the second highest data point would be. This is the 5th highest data point. This is, the 10th highest data point. And I'm sure, if you've ever taken standardized tests or gone to the doctor with your kid and had their head measured, or, their height, you should have an understanding, hopefully, of percentiles. But this is what we'd expect to see. And this is what we did see after that event. These hash marks just indicate we haven't finalized that concentration data yet. You can see that, it got really bad, it cleaned up a little bit, and then it kind of hovered a little with the kind of sediment, the amount of dirt that was in the stream, and really hasn't cleaned up to where we'd expect. We're just under the median. This is the median for the entire year. So with that, that clearer water that we see in the winter is reflected in this median number. The median for October is 30. So we are still above what we would expect to see this time of year, especially at these low flows. There's not a lot of rain events that have been kicking up extra sediment. So this is definitely elevated more than normal, more than we would expect after this event that we had with the dam failure. Total phosphorus shows relatively similar results, but it is getting closer to where we would expect this time of year. It fell below the annual median in the last sample that we have results for in October. So 0.118 milligrams per liter compared to 0.193 milligrams per liter. So we're getting a little bit better. The October median, however, is closer to 0.1. So we're getting there. We're pretty much back to normal levels. But that October median includes rain events that happened in October. And up until this last week, we really hadn't had much rain. So I think that the phosphorus, in my opinion, is probably still elevated more than it should be for this time of year under these conditions. Again, this peak concentration that we got was well above the max concentration that we've ever measured at this site with the Watershed Pollutant Load Monitoring Program and some previous work that was done here as well in the past, back to the early 2000s. Total Caldol nitrogen. So this is the type of nitrogen that's organic. So total phosphorus is sort of bound to sediment. It attaches to sediment particles, and total Caldol nitrogen does a very similar thing. So generally in streams, when we see increased sediment, we often see increased total phosphorus and elevated total Caldol nitrogen. And we saw the same things again with this. The data doesn't go quite as far. We're trying to finalize that data yet still, but you can see that this peaked a little bit later than total phosphorus and total suspended solids, up at 11.5 milligrams per liter compared to the max that we ever measured was 4.8. So this is significantly, again, higher than we would expect. So there's a lot of nutrients and sediment built up behind the dam. So when the water was released, we definitely are seeing that in our results that we have coming down the Blue Earth River. There's a couple of other things that we mentioned kind of nitrate when I showed you the flow weighted mean map. So that's that inorganic nitrogen. Nitrate binds to water molecules. So where water moves, nitrate moves. And so because it's not correlated with sediment as much, we did not see an increase in nitrate beyond what we would normally see in any given year in a rain event. So didn't have unexpected values, and it was below the max that we've measured at that station. Orthophosphate is the sort of dissolved phosphorus. So we have total phosphorus, which is all the phosphorus in the water, including that is attached to the sediment particles. And orthophosphorus is just what's dissolved in the water. So that, again, doesn't generally change very much with more sediment in the stream. And we saw that with the results where we got values that did not exceed our max that we've ever seen. They were definitely elevated to be expected with a rain event, but nothing that was as high as some of these other parameters. This I grabbed from MSNBC, just a reminder kind of for a little bit about what happened. On the left here, this is what it looked like before June 24th. So here is the dam store, here's the Ruska's house, the kind of part of the dam that has all the equipment in it. There's some other outbuildings here, power lines, all that. You can see here that, that's gone. And this was even taken before they demolished the dam store. And so this has eroded a little bit more than it did in this particular picture. I'm not sure when this is from. They took this out before it fell in the stream as well. So it took a big bite out of the bank here. It's gone further down this way, and it's gone back a little bit compared to this, but you can see that the river just went around the dam. It started carving out the sediment, the bank material on this side of the dam. And I won't really get into like why this happened, except for this was a very large event that came on very quickly, and it was really unlike anything that we'd seen on the Blue Earth River in the past. We have a drone program at the agency, so there's a person in our unit that has access to a drone and is able to fly it. So he went out a couple of times. So I'm going to show you some drone pictures. So the rest of this is all pictures and a video, hopefully, if it works, just to give you a sense of what the river looks like downstream, and to give you a sense of what the impact to habitat really is downstream of the Blue Earth River. So you can kind of see it. I mean, in some ways, like as a scientist, this is just fascinating. You know, from a social perspective, it's tragic, it's devastating. You know, what this family went through is awful, but just the power of the river and what we can see is very interesting to see how this unrolls and happens. So I will definitely say that. So this is July, this summer with the drone. We went out in October and the flow is a little bit, well, quite a bit lower. So it's kind of interesting to see some of this. It eroded just a little bit more in that few months. When we have high flows, depending on how much snow we get this winter, who knows what'll happen here next year. These are going to be old pictures, so you can see what the bottom of the Blue Earth River looked like before. So this was a float trip we took in 2023. So you can see there's all this gravel down here, some bigger rocks that are sticking out. There's class 1 rapids below the dam to where it kind of connects with, meets up with the Le Sueur and then connects to the Minnesota River. There was some good habitat downstream of the dam for sure that existed. This is a little bit older picture from 2008 that you really can see that this whole bottom is gravel for the most part. There's a few places kind of through here that do have some some sand, some silt, some finer sediment, and some clay. I mean, that's the Blue Earth River came from this blue clay, is where the name came from. So that's definitely there, but there was a lot more habitat gravel, bigger substrate in the bottom. This is just to show you from 2008, and this was relatively low water year. I'm going to show the video next, and part of the video kind of comes up to this bridge, but you can see kind of approximately where on these bridge pilings the river used to be. And that'll kind of give you a sense for where it is now. All right, so here's where I'm hoping it works. I gotta get my pointer off though, somehow. Uh-oh. I'm having technical difficulties. Sorry, guys. That is not what I wanted to do. I'm not gonna play with it, but okay, there we go. I can figure this out. So this is a video. Hopefully it's not too laggy for you. We tested it before. This is we're starting downstream of the dam and flying the drone up the Blue Earth River. You can see on the bottom of the river that the substrate now is mostly fine sediment. It really has filled in a lot of the pools that were there. They're really shallow. Some anecdotal information from the DNR fish crews that went out. Really, anywhere there's a little bit of depth and a little bit of flow, these fish, it's mostly carp and other rough fish, are concentrated into these areas. It's a little bit wobbly here. Like I said, our drone guy's a little bit new at this, but hopefully you get a sense for, you know, all of those rapids, those riffles, those rocks are all filled in. There's sediment over top of them. So pools are filled in. There's no rapids anymore. It just changed this channel significantly, which is really going to impact downstream habitat for all of the creatures that live in the river, probably for a long time to come. And it's also going to be, like I said, probably kicking down sediment, maybe phosphorus and calcium nitrogen for several years downstream into the Minnesota River, which we'll have to see what these downstream impacts are eventually as well. So we're getting obviously a little bit closer to the dam. This isn't a view that I think a lot of us got. We went out and did some of these flights. There is a significant amount of drone video that happened from this event, but I feel like a lot of it was really focused on sort of this area right here. So we're trying to utilize those drone flights to understand a little bit more about what's going on downstream, and then a little bit more on what is going on upstream. The reservoir that you see here, it wasn't really here you can see where those bridge pilings are. The water was close to the top. You can see the kind of darker area on the pilings. They had changed the way they operated the Rapidan Dam in recent years, which this will kind of stop here for the video, but there really wasn't a big reservoir of water anymore. And also it was so filled up that there really wasn't very much depth in there, but there was, a decent amount of depth and all of that sediment that was built up behind the dam. But it's lower. There's now a defined channel where it was a little bit wider and more reservoir-like up here. This is just sort of another perspective of the stream looking up towards the dam and just the amount of sediment here. Another part further downstream where really it is just filled in. Just to kind of give you a sense of how this impacted the habitat. This is the Blue Earth River here and the Le Sueur River coming in here. And I shouldn't say that there was sediment in this river. It is a river that has higher sediment than a lot of the areas. We did have sandbars, so they do exist, but they're really sort of higher. And there's more sediment than used to be there. And this is actually a picture of the dam from May of this year when I went down kayaking. So looks a lot different now, and it'll be really interesting to see sort of how that changes over time. So that is that. I'm going to see if I can figure out how to stop sharing, and we can see what questions we have.
Great. Thank you so much, Eileen. That was great. Really great overview of WPLMN and the dam failure. And yeah, this is great. I do have a question from Todd. So has there been intentional dam removal in Minnesota where MPCA performed monitoring of TSS, phosphorus, and nitrogen similar to what was collected during the Rapidan Dam failure? If so, were similar peaks observed?
Not that I'm aware of, that we've looked into it. There are a couple of monitoring stations. So for instance, on the Des Moines River, we have sampling before and after, Lac Parle. There's a few places that I think we just really haven't dug into the data. It was yeah, like was mentioned, more intentional. So I think the data is probably there to understand changes, and that definitely would be interesting to look into.
Cool. If anyone has any questions, feel free to put them in the chat, or you should be able to unmute yourselves. Oh, possibly. Sorry if you can't unmute yourselves. WebEx sometimes just doesn't allow it, unfortunately. But I'll give it a few minutes, see if anyone puts anything else in the chat. Rachel said, is there a way to restore habitat for the fish? So maybe the stream bottom.
There is, and I think that'll definitely be a discussion for DNR. So when it comes to the geomorphology, sort of the form and function of the stream, that's really their wheelhouse. So they will be making measurements. They're going to be really involved in. So for those of you who don't know, the Blue Earth County owns the dam, and they did vote to remove the dam. So the bridge has to be removed. That was relying on a lot of lateral stability from the dam sediment. So they're hoping to get that done yet. I think this fall, winter, to get the bridge removed. And then there'll be another subsequent project to put a bridge back in, but then there's also going to be a lot of work after the dam comes out to redesign and put the Blue Earth River back to what it used to be. I mean, this is miles and miles of stream downstream of the dam, so I'm not sure how much they'll actually go in and change that, but for sure, right where the dam is, that's going to get sort of reevaluated, remeandered, reset up to be something cool. It used to be rapids once upon a time, so we'll see.
Yeah. David asked, does MPCA have any programs to reduce non-point source pollutants?
Non-point source is voluntary. It's not part of the Clean Water Act. The only thing that we really do have are the buffer laws in Minnesota. A lot of these programs are done by the Board of Soil and Water Resources. So kind of our agency's part of non-point sources to say, hey, here's where it's coming from. And then we sort of pass it off to the Board of Soil and Water Resources, and then local units of government to work through different grant programs at the state level and federal level to try to address that. So it's definitely something that is important to address. Department of Ag has their sort of river friendly farmers or water, kind of water quality certification for farmers. That's happening. That's really cool and important. And there's a lot of places doing a lot of good research and education and outreach to try to increase some good practices up on the landscape. And also, I should say that we do have a little bit related to non-point source with stormwater protections in cities. So we can require certain sizes of cities to have a stormwater pollution prevention plan. So we're really able to realize some decreases in things like sediment and nutrients from maybe increased street sweeping, helping people get their leaves picked up out of the gutters in the fall, that kind of thing.
Great. So Julia asked, how far downstream did you see the visual sediment deposits? Did much of it settle within a certain distance?
So it is the entire Blue Earth River downstream of the dam to where it goes into the Minnesota River. And then we haven't done a drone flight yet from at sort of the Minnesota River downstream to see how far it went into the Minnesota River. But that's definitely something that's on my radar to see kind of how much further. But sort of those pictures that I showed of what maybe looks like more of a delta, like a dendritic stream, is really what the Blue Earth River looks like right now from the dam all the way to where it enters the Minnesota River by Mankato. So it's really impressive, the amount of impact that it had.
Great, thank you. That's all the questions we have so far. Give it another minute or two, and if any more pop in, yeah. Oh, thank you, Eric, saying that message.
They have their Minnesota River Watch school at Mankato West. Well, Mankato East is too. I'm partial to East because that's the side of town I'm on. But
Anita says, when dams are intentionally removed, how is the sediment dealt with?
so there actually was there's been multiple studies on how to remove the Rapidan Dam. It's been a conversation that's been going on since at least 2000. So in that plan that was developed, from some consultants, the idea was going to be to basically let as much water down, so like decrease the amount of water in the reservoir as far as they could, to allow some of that sediment on the sides to de-water and start to revegetate to stabilize them. And there was some sediment that they would have kind of dug out of the stream and land applied. as well to sort of get a stable stream structure involved.
Got it. Oh, Julianne has a question. Here, let me see if I can unmute you. Oh, Julianne, I think you're unmuted.
Hello?
Yes, we hear
Hi.
you.
Oh gosh. Yeah, I live in northeastern Minnesota along the Rice River, and you maybe heard about the town of Cook. They had a lot of flooding. They're actually on the Little Fork River, which is just a little ways downstream of where I live on the Rice. But anyway, right now, um, this fall, we've noticed that the water has turned more brown and cloudy. For a while, the flow was really low, but we've picked up a little bit of rain, so the water level is kind of more back to a normal level. And at first I thought, what did the river turn over? Why all of a sudden this muddiness to it? Um, so anyway, I'm curious. We also had a bridge removed and replaced just upstream from us. Um, and I'm not sure what the water looks like above that because I was thinking maybe that's played a role in what we're seeing in the river. I'm going to go for a ride today and stop at a couple sites upstream and just see if it looks as muddy as it does here. Anyway, just I
Yeah.
guess it's a observation I'm passing on. I don't know if
No.
you have a real
Yeah,
question you can answer.
that's a great observation. And I think that it's important for all of us living in Minnesota with the amount of water that we have to be connected to our water and our streams and see what's going on. When they do replace bridges, there is some sediment that gets stirred up. They do have to make some effort to contain some of that and reduce the impact, but inevitably some does. So for instance, in our watershed pollutant load monitoring program, when there is a bridge replacement, and if we sample generally downstream of that bridge, we move our sampling upstream of the bridge so that we don't capture that in our data, because we're looking at sort of long-term condition, what the stream is like normally like, and that sort of very small scale. But to your point about what you observed in the river, I think definitely rainfall could play a part in some of that, and it'll be interesting to see what you find on your ride.
Thank you.
You're welcome.
Great. I have a question from Bill. How does MPCA measure pollutants from sewage treatment plants released into rivers?
So all of the sewage treatment plants or the wastewater treatment facilities have permits with the agency, and they generally have some sort of monitoring requirement. So a lot of them have their own labs. They might buy sensors that they can put into their effluent that leaves their plant. And then they have to submit that data to MPCA, and it goes into another data system. So we have staff that are actively monitoring that permit. We have compliance and enforcement staff. So there's a lot of oversight into kind of those pollutants. There are some that are that we aren't measuring right now. When you look at like pharmaceuticals, other contaminants of emerging concern. And so as those sort of crop up as being more important or impacting downstream resources, and if there is a technology available to remove that, then they might get a permit for that particular pollutant at some point in time. So those permits are renewed on a regular basis depending on what's happening downstream.
Great, thank you. Give it another minute just to see if any last questions come in. But again, thank you so much, Eileen, for being here today and giving us all this great information. I feel like a lot of our webinars are very lake heavy, so it was really great getting to talk about rivers and streams today.
Definitely. And if anyone ever has questions, send them to Waverly, send them directly to me. I'm in the Facebook group too. So occasionally I might answer a question you have in there if I see it.
And I'll get this recording out to everyone in the next few days too. So if you have any more questions, feel free to just respond to that email. All right, great. I'll go ahead and stop the recording.